All right, guys, welcome to lesson 10.7. We're going to introduce you guys to a really important topic in trigonometry today called trig ratios. Pretty important topic, probably one of the most important ones we've addressed so far. So we're going to learn what those are first, and then after that we're going to learn how to find and calculate what those trig ratios are using two different methods. One way you can do it is by using the sides, another way you can do it is by using the angles. So we're going to be doing those things. So let's go ahead and get started here. First of all, let's talk about reference angles and sides. So first thing is, what is a reference angle? A reference angle is one of the acute angles of a right triangle that's specified. In other words, you have to pick one, and typically in the problems you're given, it'll be chosen for you. The way that I'm going to do it today is I'm going to tell you it's a particular angle by putting a circle there with a line through it. And by the way, that is a symbol, it's called theta. I'll write it up here. This is typically the variable that we use to represent angles. There. So theta is the variable that is typically used to represent angles. And so by me putting theta down here, I'm telling you that that is my reference angle. Okay. Likewise, on the other triangle over here, I could call this one theta. Now, if I do that, then I'm telling you that this one is my reference angle. Okay, so you have to have a reference angle for naming the rest of the sides in the way that I'm going to do here. So let's talk about that. First of all, we're going to talk about this side called the opposite side, and that is the leg that is across from the reference angle. So on this triangle here, if this is my reference angle, the side that is opposite that means the one that's across from it. So that would be this one over here. There's two legs on this triangle. There's this one, and then there's this one. The one that's opposite from it is the one that's farthest away. So I would call this side here my opposite side, because it's opposite from the reference angle. Look over here at this one. Which one do you guys think I would call the opposite side on that triangle? It's the leg that is farthest away from the reference angle, and so therefore it would be this one down here. Okay, let's go ahead and look at another side called the adjacent side. In the English language, the word adjacent means next to. And so the adjacent side is the leg that is next to the reference angle. So here's my reference angle. This is the one that's farthest away from it, so that's the opposite. But the one that's right next to it, in fact, the one leg here that actually makes up part of this angle is the adjacent one. So we're going to call this the adjacent angle. I'm sorry, adjacent side, my bad. So take a look at this shape over here and see if you guys can find for me what do you think would be the adjacent side? Remember, it is a leg. So not a hypotenuse, it's a leg. So which one is the adjacent side? Well, there's only one leg left, right? It's got to be this one. But more importantly, it's because this is the leg that is right next to our reference angle in that case, okay? And you guys all probably know how to identify the hypotenuse already. That is the longest side that is across from the 90-degree angle or the reference angle. So, I'm sorry, not reference angle, right angle. So the right angle is the one that looks like an L shape here in the corner. And so the side that's across from that is known as the hypotenuse, and it is the longest side, which you guys already know from previous lessons in this unit so far. So, in order to label these sides opposite, adjacent, and hypotenuse, you need to have a reference angle that tells you your starting point, so to speak. If you're here, then the opposite side would be this one over here, and the adjacent one would be this one down here. If you're on this triangle where I'm saying that this angle is the reference angle, then opposite is down here and adjacent is up here. But regardless, the hypotenuse is always the same, regardless of what your reference angle is. Now, Don't forget also we talked about this symbol here called theta, which is the variable that we use to represent angles. So don't be surprised if you see me using that. So for example, one in student practice one, what I'm going to do is I'm going to give you guys a right triangle. I'll identify the right angle, but I'll also put a theta in there to identify which one is my reference angle. And from there, we need to identify our opposite, adjacent, and hypotenuse. Okay? So let's call this one here example 1. And I'll give you guys a student practice after it. So first of all, notice that this is my reference angle. And the leg that's farthest away from that is over here. And therefore, that would be the opposite leg, or the opposite side. The leg that is closest to my angle theta is this one here, and therefore that one is what we call the adjacent side. And this third side over here, the longest one that's across from the 90-degree angle, is the hypotenuse. I don't think I spelled that right. Hypotenuse. There we go. All right, so let's give you guys a student practice and see how you guys do with labeling these things. So we have the following. Here's your reference angle. So go ahead and pause the video here and see if you can label these three sides as opposite, adjacent, and hypotenuse. And when you unpause the video, I will show you the solution. All right, so I'm going to go over the solution now. The opposite side would be this. This would be the adjacent side. And this is the hypotenuse. And there you go. All right. All right, let's go ahead and move on to our next part. For this slide, I'm going to draw a triangle, and I'm just going to label the sides. I'm going to say that this one is 3, this one is 4, and this one is 5. And what I'd like you guys to do is I'd like you to create as many fractions as you can using any two sides of this right triangle below. See if you can find all of them. Go ahead and pause the video and find as many possible fractions as you can using any two sides of this triangle. When you unpause it, I will go over the solution with you. All right, so let's say first of all I wanted to start by doing this side and this side. I could do 3 over 4, or I could do 4 over 3. That's one combination. I've got two fractions there. Another pair I could do is the 5 and the 4. So I could do 4 over 5, or I could do 5 over 4. What else could we do? I could group the 5 and the 3. I could do 3 over 5, or 5 over 3. And that's all of them. There's no more possible fractions that you could create out of these two sides. Now you might think, what's the point of that, Mr. Bailey? Well, actually, that's the whole point of today's lesson. Each of these fractions has a name, but they can only be named if you have a reference angle. So I'm going to go ahead and call this theta. If I do that, that means 4 is the opposite side, 3 is the adjacent side, and 5 is my hypotenuse. And based on that, all 6 of these have a name. Okay, now I'm going to go over this in a little bit more detail later, but for now, just so you know, this one here would be called cotangent. That's its name. This one would be called tangent. This one here would be called sine. This one would be called cosecant. This one would be called cosine, and this one would be called secant. So there are 6 different trig ratios. These are what we call trigonometric ratios. So anytime you have a right triangle and you make a fraction out of any two of its sides, you've created what's known as a trigonometric ratio. And there are 6 possibilities based on any triangle that I give you. And each of those 6 possibilities has one of the 6 names that I've gone through with you. Now you may be wondering, what's the point of that? That's for a little bit later, we'll get there. But for now, just know that they exist and we want to learn their names. So trigonometric ratios. What is it? Trigonometric ratios are fractions that are comprised, that means made up, of any two sides of a right triangle. There are 3 basic ones and 3 reciprocal ones, which are altogether 6, right? So let's talk about the basic ones first. The basic trig ratios. Now you'll notice that this is an abbreviation, SIN, but the actual name is sine. So off on the side here, you might want to write this. That's the actual name. It's sine, but it's abbreviated SIN. Notice also there's an angle here because you can't name these sides as opposite, adjacent, and hypotenuse unless you have a reference angle. So this represents the reference angle. So we have an abbreviation that represents the name, and then we have a reference angle. And then here is what the fraction is for sine. Sine is the opposite side over the hypotenuse. So if you pick any triangle, like let's go to this one really quick, and I told you that this was my reference angle here, then the sine value of that reference angle would be the opposite side over the hypotenuse. So the sine ratio would be 4/5. Okay, now we're going to do a few more examples later, but I'm just trying to bring it to life a little bit as we give you these definitions. Let's take a look at the next basic trig ratio. Like I said, there's 3 of them. The next basic trig ratio is this one called cosine. Once again, you might want to write down the actual name, but this is the abbreviation. So cosine of my reference angle will be adjacent over hypotenuse. So it's the adjacent side over the hypotenuse. And then the third and last basic trig ratio is this one, abbreviated tan, but it really stands for the word tangent. Tangent. So tangent of my reference angle is the opposite side over adjacent. So right now you guys aren't understanding why we're doing this, maybe, but I'm just explaining what we're doing. We're creating fractions out of the sides of a right triangle, and each one of those fractions gets a name. And we'll find out why we do this a little bit later. So we've learned about 3 of these names so far, known as the basic trig ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, the other half of the story is what I'll call the reciprocal trig ratios. It's these fractions here, but flipped over. So instead of opposite over hypotenuse, it's the one that's the same, it's just reversed. It's hypotenuse over adjacent. And those have names also. So let's take a look at those. So our first one here is CSC, and that stands for cosecant. Cosecant is the reciprocal of sine. So sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. Let's take a look at another one here. SEC. That one stands for secant. Secant is the reciprocal of cosine. So since cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. And then lastly, we have cotangent, which is the reciprocal of tangent. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. It's abbreviated COT, but it is spelled cotangent. Okay, so those are the 6 trigonometric ratios. So I'm calling these ones over here the basic ones because really you could do almost anything you need to do with these 3. These other 3, even though they're possible and they exist and they can be used for different purposes, they're really not as practical. They're kind of just extra information. We're going to use them, we're going to learn about them, we're going to work with them. But these guys are the important ones over here. These are just their reciprocals, okay? So that's why I'm creating this division here, but there's 6 altogether. So what is a trigonometric ratio? It's a fraction of any 2 sides of a right triangle. You need to have a reference angle so you know how to label them opposite, adjacent, and hypotenuse, but once you've done that, you can create any of these 6 trig ratios, and each one of them gets a name. Sine, cosine, tangent, cosecant, secant, cotangent, all right? Now, what we really want to do is really remember the basic ones, right? So we have a nice little trick that almost every teacher in the world, almost every trig class in the world uses, in America at least that I know of. I don't know about other countries, but to memorize these 3 over here, we have a little memory device, a mnemonic is what it's called SOHCAHTOA. It sounds kind of like I don't know, like that Indian lady that traveled, or the Native American lady that traveled around, Sacagawea, I think, or what her name was. Or maybe you think of it like soaking your toe. I don't know, whatever it takes for you to memorize it, it doesn't matter. But here it is, so-ka-toa. You're going to hear us say that over and over now for quite a while. The SOH means that sine is opposite over hypotenuse. The ka means that cosine is adjacent over hypotenuse. And the toa means that tangent is opposite over adjacent. In this little memory device, the first letter represents the name of the trig ratio, sine, cosine, or tangent. The second letter represents the side that goes on top, and the third letter represents the side that goes on the bottom of the fraction. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So it's kind of hard to memorize all of this, but it's just 3 syllables away to say the phrase SOHCAHTOA. So if you can just memorize SOHCAHTOA, then you know your 3 basic trig ratios. I don't have a memory device for these 3 over here, and I think it's probably because nobody really cares about them as much. They're just not as useful. Well, use them, and you do need to know them, but they're just not quite as common, and so that's why they don't get their own little memory device. But let's go ahead and see. What we're going to do now is I'm going to give you a triangle. I'm going to ask you to find a particular trig ratio. So let's look at example 2, which in your notes today is attached as an extra handout. All right, so this one is CSC. That's pronounced cosecant of theta. Now, the theta represents your reference angle. So before we even begin, let's label our sides. If this is my reference angle, which one is the opposite side? Hopefully you recognize that's the 12. Which one is the adjacent side? Hopefully you recognize that's the 5. And which one is the hypotenuse? Obviously, we'd have to be the one that's left over there, the 13. All right, so we've got our sides labeled. So step 1 is make sure you label your sides based on this angle that they gave us. So now they want cosecant. Well, look back at your notes and find out what is cosecant. Cosecant is what over what? Look back at your notes and see if you can recall what is cosecant of theta. It is what side over what side? You may recall it's hypotenuse over opposite. So cosecant of theta in this case is the hypotenuse over the opposite, which would be 13 over 12. And that's it. So that's our answer. So cosecant of this reference angle is 13 over 12. All right, let's do another one here. Number 2. Label your sides here. I would encourage you guys to try this on your own first, but see if you can identify what the opposite adjacent hypotenuse would be. If you need to pause, go ahead, because I am going to tell you the answers in just a moment. Here we go. So if this is my reference angle, this would be opposite, this would be adjacent, and this would be hypotenuse. Next, see if you can find out what sine of theta would equal. See if you can figure out what the sine ratio is for that angle. Now, as you guys may note, now on this one, if you need to look back at your notes, that's fine, but this is one of the basic ones. So, ka, toa. So hopefully you don't need to look at your notes for these kinds after a while. You're going to recognize, oh, this is sine, so it's S, and that's O over H, opposite over hypotenuse. So therefore, sine of theta would be 24 over 25. And there's our final answer for that one. All right, let's do one more before I let you guys practice a couple completely on your own there. Let's see if we can find out what tangent is. So, I would encourage you to try to do this one on your own as much as possible real quick. See if you can label the sides opposite, adjacent, hypotenuse, and then see if you can identify what the correct ratio is. I am going to go over the answer here now, so if you didn't get a chance to do it, pause the video. Here we go. We have opposite, adjacent, and hypotenuse. Tangent, according to SOHCAHTOA, it's opposite over adjacent, and therefore it would be 2 radical 14 over 13. Now sometimes, just so you guys know, you can reduce these. Like if you had 2 over 13, you can reduce those, but not in this case, right? 2 and 13 don't reduce, but it is possible sometimes. Another thing to watch out for is if you ever end up having a square root on the bottom, you have to get it out of there, right? Because we're not supposed to have square roots on the bottom by rationalizing it, which we talked about last class. But just a couple things to keep in mind. So I'm going to let you guys practice this. So I'm going to give you guys 3 problems to do. There you go. So go ahead and pause the video here. Take a couple minutes and answer all 3 of these, 4, 5, and 6. When you unpause the video, I'll have the solutions up for you. All right, there you go. Here are the answers. So study these, check yourself, see if you got it right, rework it if you didn't get it right, see if you can figure out what you did wrong. But we are going to move on now to our next part. So let's back up and look at our objective. Today we were talking about what trig ratios are. They're just fractions of the sides of a right triangle. There's 6 of them, all with special names. We also learned how to find those trig ratios, and we just got through doing that using the sides. And what we're going to transition to now is our last part of the objective, which is to find the trig ratios using angles. That's kind of interesting. How does that work? Well, we have to begin by answering this question here. What do the angles of a right triangle have to do with the sides? Well, let's investigate that a little bit. Let's say I have this triangle, and let's look at this angle in particular. Well, if I were to make that angle smaller, what would happen? Right now, it's opened up. It looks like I would say that's probably pretty close to about 45, maybe a little bit wider. I'd say maybe 60 degrees. Okay, but what if I were to crunch that angle down to only maybe 30 degrees? If I did that, look what happens to my triangle. The opposite side became a lot shorter, didn't it? It used to go all the way up to here, but now it's down to here. So the smaller I make this angle, the shorter my opposite side gets. Notice it didn't seem to affect the adjacent, but it also affected the hypotenuse. So that's kind of interesting, right? So the angles affect the sides. Whatever you do with this angle, that will determine what 2 of the sides on that triangle will be. Likewise, if I were to, instead of changing that angle, if I were to change this one, that would affect the hypotenuse and the opposite side here. So as you guys can see, the angles affect the sides. The size of the angles affects the sides. So that's one thing. What do the angles of a right triangle have to do with its sides? Well, the size of the angles affects the sides. Well, if the size of the angles affects the sides, that would mean that the opposite is true as well. The sides would have to affect the angles. So if you were to make the sides shorter, that would also affect the angles. So let's demonstrate this. Suppose I have this. Suppose I took this side over here, this long one here, and I were to cut it down to here instead. If I did that, and I still want this to be a triangle, I'm going to have to redraw it. As a result, this angle over here got smaller. So it seems like it's a paired deal. You can't change one without changing the other. So we can write that conclusion down too. Not only does the size of the angles affect the sides, but the size of the sides affects the angles. So if it's true then that the angles and sides have this relationship where they affect each other and they depend on each other, well then that means that the angles must have something to do with the trig ratios, because the trig ratios are based on the sides. Okay, so we can come to our third conclusion, and here it is. You can use the acute angle of a right triangle to determine all 6 trig ratios. They have to affect each other. So the angles tell us something about trig ratios. And that's because the trig ratios are based on sides. So since the trig ratios are based on sides, and sides are affected by angles, then that means the angles must tell us something about the trig ratios also. Okay. Now I want to illustrate this for you and a little bit more of an interesting fact as well. All right, so let me give you guys a special right triangle here. Let's say this is a 60-degree angle, and therefore this is a 30, 60, 90 right triangle. And I'm going to tell you right now that this side here is 4. So what would the other sides have to be? Well, you guys remember from our previous lesson that if the short side is 4, then the hypotenuse is twice that, so this is 8. And the long side is radical 3 times the short side. So you would have that. Now I'm going to give you a smaller 30, 60, 90 right triangle. Okay. This time I'm going to tell you that the sides are 2. The short side is 2. So what would the hypotenuse be? It would be 4. And what would the long leg be? It would be 2 radical 3. So even though these two triangles are completely different, I want you guys to notice something interesting about this. So I'm going to find sine of 60 for this triangle, and I'm going to find sine of 60 for this triangle. Matter of fact, I think I'll do cosine. Let's do cosine instead. It'll be a nicer answer. Now, instead of putting theta there, I'm going to actually put an angle number there. I'm going to put 60. Okay, so what is cosine of 60? Well, cosine is adjacent over hypotenuse. This is the adjacent. This is the hypotenuse. So that would be 4 over 8. Let's do cosine of this triangle over here. What's cosine of 60 on this triangle? It would be adjacent over hypotenuse still, right? So it's 2 over 4. Now they look different, right? Cosine of 60 is 4 over 8, and cosine of 60 is 2 over 4. But guess what happens? If you reduce these, you get the same answer. Okay, so cosine of 60 degrees, no matter how big the triangle is, cosine of 60 is always the same ratio. It's 1 to 2. Okay, so it doesn't matter how big the triangle is. If you have a 60-degree angle, then the cosine of that angle will always be 1 to 2. The same thing holds true for sine. Like if I did sine of 60, it would give me the same answer on this triangle as it does on this one. Or if I did tangent, it would give me the same tangent on this triangle as it would on this one. Or cosecant, or secant, or cotangent. So in other words, it doesn't matter how big the triangle is. All that matters is that they have the same angles. Now because of that, that means that your angles can tell you what the trig ratio is, because it doesn't really matter how big the triangle is, it just matters what the angle is. Now, we could do these sorts of problems with special right triangles, but there's other kinds of triangles out there. Like if I were to give you this one, and I told you this was 70, and I asked you to find cosine of 70, you would not be able to do it. The reason why is that's not a special right triangle. So even if I told you this was 2, you have no way of figuring these out. I would have to give you a second side in order to make that possible. So you don't know what this is, but guess what? Our calculators know what all the triangles are. It doesn't know just the special right triangles, it knows all triangles. So our calculator knows what we don't. It's already programmed into it. Our calculator knows that no matter how big the triangle is, if this is 70 degrees, then the ratio of the adjacent and hypotenuse will always be something. And I'm going to show you guys how to calculate that. You need to get out your calculators for this. So let's do that. So once again, I want to know what is cosine of 70. You don't have to write this down. I want you just to look. I want to know what is the cosine of 70. In other words, no matter how big that triangle is, what would the adjacent over hypotenuse be? What would that ratio be? Well, my calculator knows even though I don't, and here's how we do it. Some calculators, you're going to push the cosine button first and then 70. I wonder if this is, no, mine's not like that. Some calculators you push cosine and then 70. Some calculators you push 70 and then cosine. For my calculator, I'm going to have to type 70 first, and then I'm going to push cosine. So now, it's not going to give it to you as a fraction. It's going to give it to you as a decimal. Like when I did cosine of 60, it was 1/2. Well, that would be 0.5, right? Well, this one is about 0.342, and as you guys can see, it's an irrational number. It goes on forever with no pattern to it. But there it is. On a triangle that has a 70-degree angle right here, whatever this side is and this side, if you were to divide the adjacent side by the hypotenuse, no matter how big it is, it would always have to equal 0.342. Okay? So that is how angles can be used to find trig ratios. So our conclusion is, what do the angles of a right triangle have to do with its sides? Well, you can actually use the acute angles of a right triangle to determine all 6 of the trig ratios. So let's go ahead and do that. This is our last objective for the day, is using the angles of a right triangle to find the trig ratios. So let's go ahead and take a look at number 1. A triangle has an angle of 50 degrees, an acute angle of 50 degrees. Now, you don't have to draw this, but I'm going to. It helps me visualize it. So I'm going to draw that. I'm just going to put 50 right there. If you choose to put it on the top, that's fine. Your picture will look different than mine, but it doesn't matter. So I'm going to draw a triangle, and I'm going to put 50 where one of the acute angles is. And it's asking me, what would the ratio of the leg opposite that, which is over here, and the leg adjacent to that be? Okay, well, opposite and adjacent. Which one of our trig ratios is opposite and adjacent? Now, whichever one comes first goes on top, and whichever one comes second goes on the bottom. So I want O over A. Which trig ratio is O over A? Well, let's back up for a second and take a look. O over A is tangent. So this is a tangent value that they're asking for. All right, so what they're really asking me for, based on O over A, they're asking me to find tangent, and then they're telling me the angle is 50. So even though I don't know what O and A are, I know what their fraction is, and because my calculator can tell me that. So I'm going to get out my calculator, and I'm going to figure out what is tangent to 50. All right, so for me, I'm going to type in 50, and then I'm going to push tangent. Now for you, you might have to push tangent first. Tangent first and then 50. But so even though I don't know what the opposite and adjacent sides are, I do know that if I make a fraction out of opposite and adjacent with O on top and A on the bottom, I get 1.19 as the outcome. So the tangent of angle 50 would be 1.19. If you want to round to the thousandths, maybe 1.192. All right, let's go ahead and take a look at another one. All right, so let's go ahead and take a look at another one. A triangle has an acute angle of 70 degrees. What would the ratio of the leg adjacent to that angle and the hypotenuse be? So whichever one comes first, the adjacent goes on top. Hypotenuse is going to go on the bottom. So you can look back at your slide, or you can use our little trick here, so ka toa, and figure out which one it is. Which one has an A and an H in it? Well, it's the middle one, right? So really what they're asking me for here is cosine. And what's the angle? 70. And so I just need to type that into my calculator, and we'll get our answer. So 70 and then cosine. Now, it's possible that as you guys are doing this, there's my answer, by the way, 0.342. It's possible that as you're doing this, you're not getting the same answers as me, even though you're doing everything right. And the reason for that is because, as you guys know, there's 2 different ways to measure angles. There's radians and there's degrees. So it's possible that if you're typing this in right, but you're still not getting the right answers, because your calculator is set to radians, but right now we're working in degrees. So as you guys can see over here, it says DEG. That means I'm doing degrees. If I were to change this to radians, that'll change everything. So you have to change your calculator into degrees if it's not already giving you the right answer. Okay, so let's go ahead and let you guys practice a couple of these. So go ahead and pause the video here and answer these 2 questions, and when you unpause it, you will see the solution. All right, so for number 1, we want to find opposite over hypotenuse. which is sine, and the angle that we're working with is 35. Punching that into our calculator, we should have gotten 0.574 approximately. I'm rounding up in that thousandths place. The next one, adjacent and hypotenuse, that is cosine, and the angle is 80. So punching that into our calculator, you should have gotten 0.174. Now, something that you should notice, or take note of now anyway, from example 3 in student practice 3 is that I only gave you problems that involved sine, cosine, and tangent. Okay, now the reason I did that is because your calculator only has these on there. It doesn't have the other three. It doesn't have cosecant, it doesn't have secant, and it doesn't have cotangent. Okay, what's important to remember here though is that if you want to find these on a calculator, just remember it's the reciprocal of sine. So in example 4, we're going to be finding these reciprocal ratios, but before we do, let's write an important note down. So let me show you. So when trying to find reciprocal trig ratios on a calculator, you'll need to remember that cosecant is equal to the reciprocal of sine. In other words, it's 1 over sine. It's the flip of sine. Okay, so remember how cosecant was, or sine is O over H, cosecant is H over O. So it's going to be the reciprocal of sine. Also, secant is the reciprocal of cosine. And finally, cotangent is the reciprocal of tangent. Okay, so we're going to want to remember these three facts here as we're doing this on our calculator, because our calculators don't have cosecant. So if you ever want to find cosecant on your calculator, you're going to, that's the same thing as just typing in 1 over sine. Okay, so let's show you an example to kind of bring that to life a little bit. Here we go. A triangle has an acute angle of 32 degrees. What would the ratio of the adjacent and opposite be? So we're looking for adjacent over opposite. Now, A over O is cotangent. Now, my calculator does not have cotangent. So, but it has tangent, which is the reciprocal of cotangent. So, cotangent of 32 is the same thing as tangent of 32, but just the reciprocal of it. So what I'm going to type into my calculator is not cotangent of 32 because I can't. I'm going to type in 1 divided by tangent of 32, and that gives me the reverse or the flip or the reciprocal. Okay, so let's go ahead and do that. Now once again, different calculators work differently. I think pretty much all of them though are going to work in this way where you're going to push, if you want to type in 1 over tangent of 32, we're all going to start the same way. We're all going to start by doing 1 divided by. After that, though, it's going to be a little bit different. So 1 divided by. Now for my calculator, I'm going to push 32 tangent. You might have to do the same thing. For other calculators, you may have to push tangent 32. It's just the order. Do you push tangent first and then 32, or do you push 32 then tangent? Let's just figure out which one works for you. So for me, it's 1 divided by and then 32 tangent. And then, as you guys can see up here, it's holding the formula for me. So this is 1 divided by tangent. That's the reciprocal of tangent. And then now I have to actually push equals, though, to do the division. So equals. And there's my answer. So 1 over tangent of 32 is about 1.6 is the estimate. So let's put that down as our answer on number 1. So 1.6 is the answer there. So adjacent over opposite is cotangent, but since that's not on my calculator, I have to do 1 over the reciprocal, right? Or 1 over tangent, because that's the reciprocal of cotangent. And I get 1.6. Let's do another one here. A triangle has an acute angle of 60 degrees. We want hypotenuse and opposite. So hypotenuse over opposite. That is cosecant. So I want to figure out what is cosecant of my angle, which is 60. Well, cosecant is the reciprocal of sine. So cosecant of 60 is going to be 1 divided by sine of 60. And that's what I'll type into my calculator. So let's see what I get if I do that. 1 divided by sine of 60 is 1.55. And there it is. Okay, so those are the two answers there. So these are for the reciprocal trig ratios. Example 3 shows you how to do it for regular basic ones, but for reciprocals you got to do a little extra work because most calculators don't include cosecant, secant, and cotangent. So we'll go ahead and let you guys practice one of these yourselves. All right, so here you go. Go ahead and pause the video here. Give these two a try. When you unpause the video, you will see the solutions. All right, so there's our solutions. For number 1, you should have gotten 1, and for number 2, should have gotten about 1.035. All right, and that concludes our lesson for the day. So we'll see you guys in class to practice this stuff. Till then, have a good one.